it is. So Khan Academy, I was about to try and make myself a new account as a student. Let's go back. Let's just start over. So if you don't have an account at Khan Academy, then you can sign up. And they'll ask you if you're a learner, and you would say yeah. And they'll ask for a class code. So I'm just going to do the class code first. I think you can get your account and then enter the class code too. So you can do it in either order. And then so you would have to copy the class code from our site here. And then paste it in and add. And it says, hey, mth213. So this is math for elementary school teachers 3, the stuff I put in there, and then create a new account. And then it wants to know when you're born, make something up if you don't want to tell it. I could put in my real one today, just to keep things interesting. And then you could either enter an email address, or if you have a Google account, which I do right now, I'm just going to sign in with Google, so I don't have to remember a password or anything. Wow. And it should take a second and zip me in there. I'm probably going to get an email from Khan Academy that's going to say, please verify you are who you say you are. All right, so how does it work here? Let me see. I just did this earlier. Profile courses. Okay, so then click on courses once you get into your account. And it should have, what? Do I already have an account with a whole bunch of stuff in it? Where's my math course? Sorry, this isn't, it worked so much easier earlier. Why isn't it working now? 3 notifications. Edit courses. Why isn't it showing? Anyone else trying this with me? What am I doing wrong here? I swear I got this to work earlier. Courses up here. It should show me the course I added. Progress? No progress. Profile. This is annoying. Teachers. It says I'm a teacher. Maybe I have to enter the code again. You have successfully joined the class. Okay, where's my class? Edit courses, see all. Why is it showing me all this chemistry stuff? I must have at one time expressed an interest in chemistry. Okay, well, this is off to a great start now, isn't it? All right, maybe I have to select math, geometry. Geometric foundations. That's the only one with a get started button. Okay, let's see. All right, give me a sec here. Let's put you there. And let's go to my teacher Khan Academy. And you have 1 new student, that's probably me. Would you like to update existing assignments with new students? Oh yes, please. Okay, yeah, there it is, Geometry Foundations. Okay, so I better make a note of these order of operations. All right, so Khan Academy. Oh, I should have it in my digital notebook. Oops, where'd you go, digital notebook? All right, magic pen. Moving on to geometry in Khan Academy. Okay, so step 1, sign up. Oops. Step 2, enter the class code after you sign up. All right, somebody else could try this to make sure they can get to it. Step 3 is you go to courses. Show desktop. All right, so full screen. So then I had to go to courses and then geometry. Okay. I'll put in better instructions. Go to courses and geometry. And let's do a screenshot. This one. We want geometry foundations. It's the stuff I grabbed. And it's the only one with a get started button, which means that I assigned parts of it. These other ones you can go to there. I have them in the course, but I haven't assigned anything from them. So add to current page. Okay. Notes. So I guess this would be a step 4. Get started with geometry foundations. All right, so I have another account I was playing with here. So this is another fake me, not it's a real me, but it's a student version of me on Khan Academy. And some of these things are videos here. It doesn't seem to differentiate on this screen between what's a video and what's an exercise, but except when you click on it. So when I click on that, it brings up a video box.
And I left my situations.
I thought this was a pretty good video. He's talking about some origins of geometry and some quotes from Abe Lincoln. And so if you click on it and a video pops up, it's a video assignment. And those are optional. So these are all video assignments. And then eventually it'll say, do something. So I think this one is one that says, okay, time to do something. And it's going to ask me a bunch of questions. So then answer the question to the best of your ability and then click check. And it'll say how many you have to do in there. All right, any of you out there, did you try to get into Khan Academy yet? Or are you just hanging out watching me fumble here?
I was trying to get into it and I just did it on my phone instead of my laptop.
Yeah.
And it actually didn't give me the option, or at least I haven't found an option yet, where I can enter in the class code.
Okay.
But it had me like ask what grade I was in and then what courses I was interested in taking or like looking at. And Geometry Foundations is one, it gives me the option to start it.
Okay. Interesting. I wonder, so let me see if I see it, but if you didn't enter the course code, that means I can't see what you do.
Yeah.
So eventually you want to find a way to enter that course code. Let's see, that's my other fake students. Let's move that. This is my teacher account, and let's see who I have for students so far. I just have me and me. Okay. Yeah, so as soon as you find a place to enter that code, then that'll connect you to my account so I can see what you do. I think the Khan Academy stuff is really good. It's well done. The questions they put in there, I think, are very well done. The videos are good. The only catch is I can't connect Khan Academy to Canvas. So where that other system I was using called MyOpenMath, I could connect them. So anytime you answer questions in MyOpenMath, it automatically updated in Canvas. So in this case, I have to go look in Khan Academy and then manually update grades for you here. So I'll keep checking on you guys throughout the week to make sure you get into this particular class so that I can see what you're doing. Otherwise, we'll figure out some other way to make it happen. And then I'll put those instructions on the website that I just went through to get your account connected to my account in Khan Academy. All right, let's do some math. So, new page. So these are some magic board basic concepts of geometry. So in a lot of classes you've had with me before, or for a lot of topics, I've asked you to tell me what something means. So I got 3 words I'm going to put up here. I want you to write down what you think they mean and maybe have a little example. So one of them is the idea of a point. What is a point? What's a line? And these basic concepts are of geometry. And the other one is plane. So what do you think a point is? Can you give me an example? What do you think a line is? Can you give me an example? And what do you think a plane is? So think about that for a moment. Write some down. There is a jumping spider crawling around my workstation. He's been all over the place. They are very cool spiders. All right, so here's me trying to sketch a point. You can kind of barely see that sucker up here. There's my point. Here's my line, and here's my plane. So what is a point? Anybody want to chime in or text in, chat in?
Could you say a point is something indicating an area, like a significant area or a specific area?
So an area? So, okay.
Yeah. Well,
yeah, so when I think about area, I'm thinking of like, you know, this circle has an area. Do you mean like a position maybe?
yeah. So for instance, like on your, so what I'm trying to think of is if I had a line and I had a point like in the middle, that would be the maybe the origin.
Oh, yeah, like when we're doing graphs. Okay, so let me bring up a situation where I can do that. Let's see. Although I could do it here, I got a cooler place to play. One of my favorite tools for doing geometry is called Geogebra, and we'll play with this a little bit in the next few weeks. There's a graphing calculator version, there's a geometry version, there's all these different things. So I'll put a link to this. And then, so Geogebra geometry. And then I'm going to ask Geogebra to show me axes and a grid. So major grid lines. All right. So like here, if I put a point right there, right, that's marking the position where x is 0 and y is 0, right? So yeah, so a point is a position in space. All right. And then like somewhere in between in this little square over here, I could put another point. And let's see, they'll tell me what point I clicked on if I can find the right button here. Maybe, it says I clicked on the point, blow this up a little more, 1.66-ish, 0.45-ish. And interesting, when I zoom in on that, the point kind of blew up a little bit. But how big is a point in space? I can keep zooming in on it. And notice it's zooming in on the values on the side and on the bottom. So I'm glad you brought up the idea of area too, because that's the weird thing about a point. It's a position without any area, which is kind of like, how can you have a position without any area? And you kind of can and you kind of can't. If I zoom in on this screen right here, that little red blob there is going to look bigger and bigger and bigger as I zoom in on it. And a position doesn't really have area. It's just this like microscopic dot somewhere. But we have to make it bigger, otherwise we can't see that position. So we use a bigger circle than the position should be. So a point, yeah, it's a position. That's one way to think about it. But what is a position exactly? That's a little bit sketchy to find. One thing that is weird about a point is it has no size. Because we can keep zooming in on that position, and the position doesn't get bigger. We're just zooming in. It's just really weird idea. So we'll have to come back and investigate that. Does anybody else want to comment on the point idea? Not at the moment. Yeah, Kayla, a plot on a graph, right? So we can plot a point, that's a position. And when we zoom in on it, it's kind of weird because it looks like it's getting bigger, but the position can't be getting bigger. It's just we're just zooming in. It's a very strange idea. All right, so what's a line? So I drew these 2 points and then I connected them. But what and somebody would say, yeah, that's a line. Some people would say that's a line segment, and that's a slight distinction we'll get into a minute. So line segment. Anybody want to comment on a line? Checking out the chat, nothing yet, no voice. Oh.
Isn't a line something that goes on forever, both in either direction?
Yeah, that is one thing we say about a line. Let me zoom out on this sucker. Okay, so I can see A and B there. So in the geometry version of GeoGebra I'm using, I can go into this, what they call the algebra mode that describes the things on the screen, and the kind of the tools mode where I can do stuff. So if I were to make a line between using points A and point B, it's just going to go on forever. And so if I try to, oops, stop it, GeoGebra. Control Z, no, there's an undo button somewhere. Where'd it go? Oh, they moved the undo button. Right click. I can't delete it either. Okay. The cool thing about these pieces of software is they're always updating, and that's also the bad thing because it's now different. Oh, I know. Go to the move thing and then click on it and then trash it. There we go. Trash. All right. So I want move. So if I drew that line from A to B, and GeoGebra kind of presents this concept in a good way, it just, oops, cancel. As I keep dragging out to the right here, just that line keeps going forever and ever and ever and ever and ever. Yeah. So a line is this straight thing that goes on forever. All right, what else do we want to say about it? So a line is straight. It goes on forever. Can I measure a line? Now I can measure a line segment, right? I could whip out a ruler and tell you how far it is from here to here. But if it goes on forever, how could I measure it, right? It doesn't end. I can't measure it. So a line we can't measure because it goes on forever. A segment, which is like a straight distance between 2 points, that I can measure. How thick is a line? Well, on this screen, it's whatever that thick is, but when I zoom in, it stays the same thickness, even though everything around it got bigger or smaller, depending on your perspective. So that's another weird idea. All right, so again, the idea of point and line seemed kind of simple, but there's some weird stuff behind it. So just a couple of things to point out here. It's hard to define a point, it's hard to define a line. In geometry, they're referred to as undefined terms. Oh boy, that came out bad. Undefined terms. I can kind of show you what it is, but it's really hard for me to write a clear definition so that you understand what I understand. But I can show you a bunch of examples of what I think a point is. Same thing with a line. How could I define it? A line is a straight line between 2 points. The problem is I used the word line in the definition for line, so that doesn't work. And then the other question is, what does straight mean? And what does forever mean? Those are 2 other strange ideas. Okay, straight is not curved. Okay, what do you mean not curved? So these things are very, we get it, we think we do, like the edge of a paper we believe is straight, we believe a ruler is straight. So we have these examples of straight, but defining it is a whole nother thing. So a point is something we say is an undefined term, a line is an undefined term. We just have this intuitive understanding instead. And we can draw pictures and talk about it, but just writing a sentence or 2 that says, hey, this is what it is, it's not really possible because you end up using the word in the definition. Or you just kind of cheat around it. What is a point? A point is a position. What is a position? A position is a point in space, right? So I used point to define position, I used position to define point, and I have a problem. We came up with this problem before in the course too. All right, so we got this idea about what a point is, but it's weird, it's this undefined thing. It's also this abstract idea. Can you find me an actual point in your world? I mean, I have things I would call dots, but if I zoom in on them, they have area, right? Because some kind of ink or paint had to be used to make them. So it's abstract in that it exists in theory, in the theory of geometry, but doesn't exist in reality. And if you take any line that you think is straight in reality and you zoom in on it with like a magnifying glass or a microscope, you'll find that it's actually quite jagged. These are these weird abstract ideas. They're undefined in a sense, but we have this intuitive understanding of them. And then there's the idea of a plane. And so a plane is this flat region, and it goes on in each direction forever. Oops, that was a very good one. And there's lots of different planes. My floor is kind of a plane. My ceiling is kind of a plane. One of my walls would be another plane. So a point, line, and plane are some basic ideas in geometry. And I almost wrote with a regular pen on my tablet. That would be bad. Okay, so let's see some other ideas we need to take a look at, and we are almost out of time for today. Where'd my notes go? Okay, point, line, plane. Let's get into some definitions and angles next. So these guys are all kind of undefined terms that I use to define other stuff, like a line segment. It is a line between 2 points, beginning at one point and ending at the other. One of the properties of a line segment is it has what we can measure as length. It's a measurable length. And I had an example earlier of one. So let's say I've got a grid in front of me here, so I could put a point there, and then let's go over 1, 2, 3, 4, and up 1, 2, 3, put another point there. If this grid represents 1 unit each, then according to the Pythagorean theorem, the line that connects those 2 points should measure 5 units long. So I have some point A here, so that's not a pen. And I have some point B over there, and then I have this segment in between that's measurable. So the segment would be called AB with a straight line over the top. And that's how we denote a segment. And then if I did something like wrote the letter M parentheses A, B, the bar with AB, that says measure line segment AB. And in this case, I would measure that to be 5, whatever these units are. Another idea related to a line is a ray. An array is part of a line starting at 1 point and going through another point following that direction forever. So in some sense, it would be half of a line. So if I had a point here, point A, and another point over here, point B, I would denote the segment there by starting at A, if A was my starting point, and B was my point to pass through. And then we put a little arrow on one side to indicate that's the direction, but this right here is the end point. So the end point is A. And then we have this forever direction going through point B. And so we would, this would not have length because it goes on forever, but it does have direction. So like for properties, for array, we could talk about its direction, which we'll get to in a sec. And then the notation for that would be an AB, and the endpoint comes first, usually, and then we draw the direction toward the other one. So notice a segment has no arrows on it. A ray has one arrow on it away from the endpoint. And as opposed to a line, like on the previous page, if this were actually a line here that went on forever from A through B, then I would do AB, and the line on top would have an arrow on each side. So you'll see that in the book and in the Khan Academy stuff. Next, angles are what we need to get into next, and that'll be enough for today, and we'll just scratch the surface of angles for now. So draw a quick picture of an angle and then make some kind of comment about it. When I just saw a comment here, let's see. Yeah, for a line, that's a good one. Hang on, we'll go back a sec. Previous page, about what is a line? This page here. You could say it's connecting points, right? But the straight's got to get in there too. A line is also, in a sense, a collection of points, because every position I go to on that line, I can identify a point. How many points live between A and B? And that's the weird thing. Between any 2 points, there's infinitely many others. We talked about that when we were working with fractions and decimals. So between 2 points, there's infinitely many other points, but then the line heads out infinitely in one direction and the other. So then we get this weird infinity stuff going on. So geometry, it sounds, some of these simple concepts sound simple, but it turns out they're deep and complicated. All right, oh, wrong button. Next page. All right, angle. What is an angle? So I can draw what I think an angle is. Let's go, actually, let's start different. Let's start here-ish. Let's make that one line, and this the other one. And then in between from here to here, I have an angle. Anybody want to tell me what they think an angle is?
Maybe a degree. That's,
All right, so we measure angles with degrees. What's a degree? So an angle actually isn't undefined, but it is a little bit tricky to define. So I've got these two rays up here. So let's label things a little better. Let's say the endpoint is A, and this ray up here passes through point B. And then I have another point down here called point C. And so I've got a ray going from A through C. And so that gives me this angle. So when we talk about angles, we make a little symbol like that. And then we always put the central point in the middle. So I could call this angle BAC, or I could call it angle CAB. But notice the A has to be in the middle because that is the central point of this angle right here. So one way we could talk about angle, besides using the word degree, we'll get to that in a second, it's a measure of rotation. One ray has to make to line up with another ray. That has the same endpoints. Endpoint. So imagine that I take a virtual version of this AC here, and I drag it so the A stays fixed, and I drag C toward B. That rotation that I sweep through is one way to talk about an angle. There's a couple of other ways to talk about it too. And so I'm going to draw a picture of a couple of those, and then that'll be enough. So degree is definitely an interesting thing, because like, what is a degree really? Where did it come from? We talked a little about this last term. New page. How did that? My pages got out of order, darn it. Hey, when that happens. Fix that later. All right, so let's see. I need to draw myself a circle. Oh, my pen just locked up. All right, here's my best circle today. That's not too bad. And then a circle, usually has a center there. And let's just say that this circle, if we put like a X and a Y axis through it, through the middle here. So let's say that's the Y axis and this is the X axis. Let's say it has a radius of 1. So we got a center here, 0, 0, and we got a radius of 1. And we'll cover circles in more detail later. So a couple of ways to think about that is, let's just say I'm going to try and cut this quarter circle in half, so that I'm trying to make 1/8 of the circle. Now I could have just as easily taken 1/4, which would be up here, but there's this angle I made here, going from here to there. And two ways to think about that angle, and we'll get the degrees in a second. Would you agree that I could go all the way around the circle? And all the way around would be 1 revolution. So this angle right here, if I say that's A, B, and C, so angle BAC, its measure is 1/8 of a rotation. And a rotation means go all the way around. Instead of the word rotation, you could use turn. We could have a full turn. In this case, I have 1/8 of a turn. So it turns out using the word rotation or turn would be one way to measure an angle. Another way people have discovered to measure angles, and we'll get to degrees in just a second, is if the circle has a radius of 1, then they measure the area inside that circle of radius 1, and that area is the angle. So another thing we could say for the measure of this angle BAC would be the area of the, let's see, try again. This part of a circle like this, starting at the middle, is called a sector. So it'd be the area of the sector of a circle of radius 1. And it turns out this is a very popular way, even though you may not have heard of it before. If you remember, anybody remember the area formula for a circle? I think we talked about it last term. We'll go over it again this term. Area for circle, pi times exactly.
Squared?
Yeah, pi times the radius squared. The radius here is 1, so that means the area of this whole circle would be just pi. And so then I want 1/8 of that circle. So this angle right here would have 1/8 of pi, which we might instead write as pi over 8. Oops, I lied. Excuse me for lying so severely. I meant to say circumference. Circumference, not area. And I'll explain why it's circumference later. Oops, let's pull out that shading. Okay, so I only want the circumference part. So that means this is incorrect. Circumference is 2 times pi times the radius. So for us, that's 2 times pi times 1, or 2 pi. So that would be 1/8 of 2 pi, which is 2 pi over 8, or pi over 4. Would be one way to measure this angle. And one way to think about it, the simplest circle you could make, if you think about plotting points, would be put it at the middle, the origin, and then just make the radius 1, because that's the easiest radius you could have. So we've got a rotation, we got part of a circumference of a circle, and then the third way, so let's say that's way number 1, this is way number 2, and way number 3 would be this idea of degrees. Anybody remember how many degrees are in a full rotation?
360.
Yeah, so 1 rotation equals 360 degrees. And we use this little upper superscripted circle for degrees. Why 360? Anybody know? What's so nice about 360? Answer, it's close to the number of days in a year. And so I just had a chat come in. What do we got? Mayan numbers. Yeah, they were totally into the 360 thing. And they actually knew there were more than 360 days in a year. They knew also that there were actually more than 365 days, that it was 365 plus a little bit, which is kind of wild for the time that they discovered that. That's just the same number. My pen must have froze. Yeah, so 360 is easier than 365, and it's actually not 365, it's 365 and close to a quarter days per year. That's why we have to have a leap year every 4 years, except for every 4th century. I think that's the rule, something like that. Yeah, so it's kind of an arbitrary number in some sense, because we happen to be on this planet that spins at a certain rate and goes around the sun at a certain rate. And then somebody said, hey, 360 is a nice number, let's use that. But it turns out it's pretty arbitrary, and it doesn't have any really good mathematical meaning, except a lot of numbers divide into it, which is kind of nice. So if 360 is all the way around and I went 1/8 of the way around, then if I divide 360 by 8, I should find another measure for my angle. What was I calling it? BAC of 45 degrees. So we could call it 1/8 of a turn. We could call it pi over 4. When we use the circumference of a circle of radius 1, this is called a radian. And on calculators, they might often abbreviate it RAD. And so you might see on some calculators, you have a choice between degrees, which the calculator might call DEG, and radians, RADs. And they usually give another one, gradients, which we're not going to get into here. So there's a bunch of different ways to measure rotations, angles. I like rotations or turns. Degrees are kind of arbitrary, but we're stuck with them because they're kind of in our society all over the place. But mathematically speaking, the best one is really the radian. But you'll only get into that if you get into engineering type stuff. All right, that is more than enough for today. Let's stop here. So please jump in and do the reading. Linked here, and it's also in the McGraw-Hill Connect page, and there's probably a couple other places you can grab it in Canvas. That reading is due tonight, so jump in there and answer those questions that nice woman asks. And then as soon as you can, get logged into Khan Academy. If you have any trouble getting an account, let me know. I'll send out an announcement, which you'll also get in your inbox, describing the steps to get into Khan Academy. And if there's any trouble, we can troubleshoot that next time. And then Wednesday, we're going to do the paper circle activity. I got to polish it up a little more. And then we'll probably just stop with the learning forum. So we'll have the reading, the homework, the activity I'll go over in the next session. We'll get to play more with angles then, and some of the other ideas presented in the book and in Khan Academy. And then we have the questions place where you guys need to post a question and or an answer to something. All right, any final notes before we head out, part ways? All right, well, it was good of you all to join me. Good luck with your math and other activities in school and in life. I hope you're all well, and I will see you Wednesday if I don't hear from you sooner. Have a great night. Bye-bye.